So now we're starting to get into the nitty gritty of simple harmonic motion, and we're going to cover the simple pendulum. So at this point, you should probably know what a pendulum is, but for those who don't, it's essentially a small object attached to a spring, or string or spring rather, tends to be a string, and allowed just to simply move along one plane. So if you've ever seen a Newton's cradle, which you probably have if you watched the series through, so in a Newton's cradle, there's a bunch of small objects with a string attached, which is essentially just a bunch of mini pendulums. So we know that if something is obeying simple harmonic motion, that the acceleration is negative of displacement. So one thing that we can actually do here, which I'll write sort of in more maths-like, so we know that force is proportional to the negative of the displacement, which is the restoring force on the string. So this is your F. So after that, we can say that ma is proportional to negative x, which we can then write as m times delta v over delta t is again proportional to negative x, which we can then say that because if we bring this t over, we're going to get that the velocity is just proportional to negative x times the change in time, which is a bit weird in a way, but it will come to fruition slightly later. Again, where m is scalar, so m is essentially almost like a proportionality constant in a way. So, yeah, we can also see here that at this case, the force is in the opposite direction or perpendicular to the velocity, which you can kind of see in a way. So the velocity was sort of down this way. If you brought this vector down, you can see that they're perpendicular, which is essentially what this is showing. So at any point, the velocity is perpendicular to the restoring force, and thus somewhat of the restoring acceleration.